If intelligent life is common, then the universe should not be silent. For billions of years, stars have been born, planets have formed, and the same laws of physics that gave rise to life on Earth have shaped countless other worlds across the cosmos. If life is not unique to our planet, then somewhere in that immense expanse, another civilization should have emerged long before humanity ever existed. Some may have discovered science. Some may have explored their own worlds. And some could have become unimaginably more advanced than we are today. If civilizations have had billions of years to rise, evolve, and spread across the galaxy, where is everyone? For decades, humanity has searched for an answer. We have pointed our most powerful instruments toward the stars, listened for signals from distant worlds, and searched the universe for even the smallest hint that we are not alone. Yet despite every discovery and every technological breakthrough, we have never found a single piece of confirmed evidence that another intelligent civilization exists. The deeper we explore the universe, the stranger that silence becomes. Is intelligent life extraordinarily rare? Are advanced civilizations separated by distances too vast to overcome? Have we been searching in the wrong way? Or does the universe hide a truth we have yet to understand? For decades, this single question has challenged scientists, astronomers, and physicists around the world. It has inspired countless ideas, extraordinary debates, and one of the most profound scientific mysteries of the modern age. This mystery has a name. In the summer of 1950, during a casual lunchtime conversation at Los Alamos National Laboratory, the Italian-American physicist Enrico Fermi asked a question so simple that it seemed almost impossible to answer. Surrounded by some of the brightest scientific minds of his generation, the discussion had turned to the possibility of extraterrestrial life. Then Fermi paused and asked a question that would echo through the scientific community for decades. Where is everybody? At first, it sounded almost humorous, but behind those three words was a profound scientific puzzle. If the universe is as vast and as old as it appears to be, and if the conditions for life are not unique to Earth, then intelligent civilizations should have had more than enough time to emerge, develop advanced technology, and leave some trace of their existence. By all reasonable expectations, the universe should show signs that we are not alone. Yet after decades of scientific exploration, humanity has found no confirmed evidence of another intelligent civilization. No confirmed extraterrestrial signals. No unmistakable alien technology. No confirmed contact. The more our understanding of the cosmos has grown, the more puzzling that absence has become. This contradiction became known as the Fermi Paradox. It is not proof that aliens exist, nor is it proof that they do not. Instead, it represents one of the greatest unanswered questions in modern science. A paradox born from the gap between what many scientists expect and what we have actually observed. Over the years, astronomers, physicists, biologists, and philosophers have proposed countless explanations. Some suggest that intelligent life is extraordinarily rare. Others believe advanced civilizations may be impossible to detect. And some theories propose possibilities far more surprising than anyone could have imagined. So what do scientists really know? And what remains one of the greatest mysteries in the universe? To answer those questions, we must begin with something extraordinary, the universe itself. Chapter 1. A universe that should be alive. The search for extraterrestrial life begins with a simple realization. Earth is no longer the only known world in the universe. For most of human history, we had no idea whether planets even existed beyond our solar system. Today, that picture has changed dramatically. Thanks to decades of astronomical discoveries, scientists now know that planets are not rare exceptions. They are a natural part of how stars form. Almost everywhere we look, we find new worlds waiting to be explored. Our own Milky Way galaxy alone contains hundreds of billions of stars, and many of them are now known to host planetary systems. Beyond it lie hundreds of billions of other galaxies, each filled with their own stars and planets. The observable universe contains numbers so immense that they are difficult for the human mind to comprehend. Even if only a tiny fraction of those worlds were capable of supporting life, the total number of potentially habitable planets could still be astonishing. Yet having a planet is not enough. Life, at least as we understand it, requires the right conditions. A world that is too close to its star may become so hot that liquid water cannot survive. Too far away, and any water may remain permanently frozen. Between those extremes lies a region astronomers call the habitable zone, the distance from a star where temperatures may allow liquid water to exist on a planet's surface. It is within these regions that scientists have discovered a growing number of intriguing worlds, each becoming a new target in the search for life beyond Earth. But even the habitable zone is only part of the story. A planet's atmosphere, chemistry, magnetic field, geological activity, and long-term stability all play critical roles in determining whether life could emerge and survive. Earth itself is the result of billions of years of favorable conditions working together. The question scientists continue to ask is whether those same conditions have occurred elsewhere, or whether our planet is an extraordinarily rare exception. As new discoveries continue to reshape our understanding of the cosmos, one conclusion has become increasingly difficult to ignore. The universe appears to contain an extraordinary number of places where life could, in theory, exist. And if nature has repeated the same process even a handful of times, then somewhere beyond our solar system, other civilizations may have had millions or even billions of years to develop before humanity ever appeared. If so, why haven't we found even one? Chapter 2. Listening to the Cosmos. Knowing that other worlds exist is only the beginning. The real challenge is determining whether any of them are home to intelligent life. Unlike planets, civilizations cannot be discovered simply by taking a photograph. Across the immense distances of space, even the largest structures imaginable would appear invisible. If another civilization exists, scientists must search for indirect evidence, subtle clues that distinguish technology from the ordinary processes of nature. One of the first ideas was surprisingly simple. Every civilization that develops technology may eventually discover radio communication. Radio waves travel through space at the speed of light and, under the right conditions, can continue for enormous distances. If another civilization also uses radio technology, even briefly in its history, those signals might one day be detected by another world. This possibility inspired the search for Extraterrestrial Intelligence, or SETI, a scientific effort dedicated to listening for artificial radio transmissions that cannot be explained by known natural sources. As technology improved, so did the methods of the search. Modern observatories no longer rely on radio signals alone. Scientists now examine the light passing through distant planetary atmospheres, looking for chemical combinations that may indicate biological activity. Others search for technosignatures, observable evidence of advanced technology. An unusually powerful source of energy, a repeating laser pulse, or any signal that appears deliberately structured could become the first indication that intelligence exists somewhere beyond Earth. The search has also become far more sophisticated than simply waiting for a message. Powerful computer systems now analyze enormous amounts of astronomical data, searching for patterns that human observers might overlook. Artificial intelligence is increasingly being used to identify unusual signals, eliminate interference, and recognize subtle anomalies hidden within billions of observations. Every year, the search becomes faster, more precise, and more comprehensive than ever before. Yet despite decades of listening, observing, and analyzing the cosmos with increasingly advanced technology, no discovery has provided confirmed evidence of another intelligent civilization. This does not prove that humanity is alone. It only tells us that, so far, our search has not revealed the answer. That unanswered result has forced scientists to consider a deeper possibility. Perhaps the mystery is not a failure of our instruments, but something far more fundamental about the universe itself. To understand that possibility, we must examine the scientific ideas that attempt to explain why the cosmos has remained so remarkably quiet. Chapter 3: Explaining the Silence. By this point, the question had become impossible to ignore. If the search had revealed no confirmed evidence of intelligent civilizations, then scientists needed to consider another possibility. Perhaps the silence itself was not a mystery waiting to be solved, but a clue pointing toward an answer. Over the decades, researchers from astronomy, biology, physics, and planetary science have proposed numerous ideas to explain why the universe appears so quiet. None of them have been proven, but each attempts to answer the same fundamental question from a different perspective. One possibility is that intelligent life is far rarer than we imagine. While simple microbial organisms may exist on many worlds, the journey from single-celled life to a technologically advanced civilization could require an extraordinary combination of events. On Earth, life appeared relatively early in our planet's history. Yet complex animals took billions of years to evolve, and intelligent humans emerged only within the last fraction of that timeline. If even one critical step in that process is exceptionally unlikely, then civilizations capable of exploring space may be incredibly uncommon throughout the universe. Another explanation suggests that civilizations do emerge, but very few survive long enough to become detectable. This idea is known as the Great Filter. Somewhere between the formation of a habitable planet and the development of an advanced interstellar civilization, there may be a barrier that almost no species successfully crosses. That barrier could take many forms, including environmental collapse, global war, resource depletion, or other challenges that prevent civilizations from reaching the stars. One of the most unsettling questions raised by this hypothesis is whether humanity has already passed the Great Filter or whether it still lies somewhere ahead of us. Some scientists have proposed that advanced civilizations may exist, but remain invisible because they choose not to reveal themselves. Known as the zoo hypothesis, this idea suggests that humanity could be intentionally observed while being left undisturbed, much like wildlife in a protected nature reserve. Although there is no evidence supporting this hypothesis, it illustrates just how many possibilities scientists have considered while trying to explain the silence. Other ideas focus on the immense scale of the universe itself. Even if intelligent civilizations are relatively common, the distances separating them may be so enormous that meaningful communication becomes extraordinarily difficult. Civilizations may rise and disappear millions of years apart, never existing at the same time or close enough to detect one another. In a universe measured in billions of years and trillions of kilometers, two civilizations could spend their entire histories unknowingly passing each other, like ships crossing a vast ocean in complete darkness. At present, none of these explanations has been confirmed. Each represents a serious scientific attempt to understand one of the greatest unanswered questions in astronomy. The silence has inspired remarkable ideas, but no definitive answer. And perhaps that is the most important conclusion of all. The Fermi Paradox remains unsolved not because scientists have stopped searching, but because the universe has not yet revealed which explanation, if any, is correct. To understand where the evidence truly stands, we must separate scientific discoveries from speculation and examine what researchers actually know today. Chapter 4: What the Evidence Reveals. After decades of exploration, one conclusion has become clear. Humanity has learned an extraordinary amount about the universe, but the central question remains unanswered. The search for extraterrestrial intelligence has not ended in failure. Instead, it has transformed our understanding of what is possible and what still remains unknown. Separating established scientific evidence from unanswered questions is essential to understanding the true nature of the Fermi Paradox. The evidence tells us that planets are common throughout the universe, not rare exceptions. Thousands of exoplanets have already been confirmed, and many more are expected to be discovered as observational technology continues to improve. Scientists have also detected complex organic molecules within interstellar clouds, on comets, and in meteorites, demonstrating that the chemical building blocks associated with life are widespread throughout the cosmos. While these discoveries do not prove that life exists elsewhere, they show that the ingredients required for life are not unique to Earth. Scientists have also made remarkable progress in studying distant worlds. Modern space telescopes can analyze the atmospheres of exoplanets by examining how starlight passes through them. This allows researchers to search for potential biosignatures, chemical combinations that could indicate biological activity. Although several intriguing observations have attracted scientific attention, no atmospheric measurement has yet provided conclusive evidence that life exists beyond our planet. Every potential discovery must withstand rigorous testing before it can be accepted by the scientific community. The same standard applies to the search for intelligent civilizations. Over the decades, astronomers have detected many unusual astronomical signals, but every confirmed case has ultimately been traced to natural phenomena, human technology, or remains under scientific investigation without confirming extraterrestrial intelligence. To date, there has been no verified radio transmission, technosignature, or observation that demonstrates the existence of an intelligent civilization beyond Earth. This distinction is what makes the Fermi Paradox so remarkable. The paradox does not arise because scientists have found evidence of aliens. It exists because modern astronomy suggests that the universe appears capable of supporting countless opportunities for life, while every carefully verified search for intelligent civilizations has so far produced the same result: no confirmed detection. The contradiction lies between expectation and observation, not between belief and disbelief. Science does not claim that humanity is alone in the universe, nor does it claim that intelligent extraterrestrial civilizations exist. The most honest answer, based on the evidence available today, is that we do not yet know. Every new telescope, every space mission, and every scientific discovery brings us closer to answering one of humanity's oldest questions, but the final answer has not yet been found. That uncertainty is not a weakness of science. It is what drives the search forward. Chapter 5. The search continues. Although the Fermi Paradox remains unsolved, humanity's search for an answer is far from over. In many ways, it has only just begun. Every generation has inherited more powerful tools than the one before it, allowing scientists to observe the universe with increasing precision. Questions that once belonged only to philosophy can now be investigated through astronomy, planetary science, chemistry, and physics. Rather than relying on imagination alone, researchers are developing new ways to search for evidence using the scientific method. One of the greatest advances is the ability to study distant planets in remarkable detail. Modern observatories are beginning to analyze the chemical composition of exoplanet atmospheres, searching for combinations of gases that may be difficult to explain without biological activity. Future space telescopes are expected to examine smaller, Earth-sized planets with even greater sensitivity, giving scientists their best opportunity yet to search for potential biosignatures on worlds orbiting distant stars. The search for intelligent life is also evolving. Instead of focusing on a single type of signal, researchers are exploring a much broader range of possible technosignatures. These include unusual patterns of energy, artificial light, powerful laser emissions, and other observable phenomena that advanced technology might produce. At the same time, advances in artificial intelligence are helping scientists process enormous amounts of astronomical data, making it possible to identify subtle patterns that would have been impossible to detect only a few decades ago. Yet even with these remarkable advances, science offers no guarantee that a discovery will happen tomorrow, or even within our lifetime. The universe is unimaginably vast, and the absence of evidence cannot be interpreted as evidence of absence. It is entirely possible that the answer lies beyond the reach of today's technology, waiting for future generations equipped with instruments that have not yet been invented. Throughout history, humanity has repeatedly answered questions that once seemed impossible. We learned that Earth is not the center of the solar system. We discovered that our sun is one ordinary star among billions in the Milky Way. We confirmed the existence of planets orbiting distant stars, something that remained purely speculative for most of human history. Each discovery expanded our understanding of the universe and reminded us that today's mysteries can become tomorrow's scientific knowledge. Whether the Fermi Paradox is eventually solved or remains one of science's greatest unanswered questions, the search itself represents something extraordinary. It reflects humanity's willingness to question, to explore, and to follow the evidence wherever it leads. Every observation, every new mission, and every technological breakthrough brings us one step closer to understanding our place in the cosmos. And perhaps, somewhere in the vast darkness between the stars, the answer has been waiting all along. If this journey through one of the universe's greatest mysteries sparked your curiosity, don't let it end here. Leave a like if you enjoyed this documentary, share it with someone who loves space and science, and subscribe to Cosmic Frontier Studios for more fact-based explorations of science, astronomy, physics, and the most fascinating scientific theories. Every documentary is grounded in real research, scientifically accurate explanations, and the latest scientific understanding. When we explore scientific theories, we present them as theories, not as established facts, while following the evidence wherever it leads. The universe is full of questions we've yet to answer. Until next time, keep looking up and keep wondering.